These are the notes for section 2.3, product and quotient rule. We now know how to find the derivative of a polynomial function. So now we're just going to be building on top of that rule. So the product rule is the formula used to find the derivatives of products of two or more functions. So when we find, if we're trying to find the derivative of two separate functions being multiplied together, it's not quite as easy as just finding the derivative of one function and then multiply it with the derivative of the other function. So there is a slightly more involved step than that, even though we do involve both functions' derivatives, but they have to be combined together using this rule. So the derivative of two functions being multiplied together, let's say the first function is f of x and the second function is g of x, we're going to take the derivative of the first function and multiply it with the original second function plus the original function f of x times the derivative of the second function g prime of x. So a way to say this quickly with the product rule is f prime g plus fg prime. Okay. So here's an example. Y equals 3x minus 2x squared times 5 plus 4x. Okay. So we're going to let f of x represent the 3x minus 2x squared. We'll let g of x represent the 5 plus 4x. We see that these are two separate functions that are highlighted by these parentheses. So now we're going to apply the product rule. So f prime g plus fg prime. So first thing we need to do is need to find the derivative of f of x. So the derivative of 3x minus 2x squared will simply be 3 minus 4x. So this will take the place of the f prime position times g of x. So the g of x is just the original second function, untouched, unchanged, and that will take the space for the g function in the product rule, plus the original f function, so that'll be just 3x minus 2x squared, times the derivative of the second function, so then the 5 plus 4x, we need to find the derivative for that, so 5 goes to 0, it's a constant, and 4x simply becomes 4. So now if we were to multiply and expand this out, we would have the derivative rule, the derivative function. So this technically is a derivative function, but we can clean this up further if needed to by expanding. Okay. Something else that we can do is we could avoid, in this case, we could avoid the product rule by simply expanding this into so that we get rid of all the parentheses, and then if that were the case, then we can treat each like a polynomial that is a term that is separated by plus or minus, and if that's the case, then we can just apply the power rule for each term. Okay, but here we're just practicing using the product rule, even though we could have expanded this one out and then applied power rule for each. Okay, the second formula is with quotient rule. So if we want to find the derivative of functions that is the result of the quotient of two other functions, then we can use the quotient rule. So let's say we have f of x and g of x. F of x representing the function in the numerator and g of x representing the function in the denominator. So the rule that is applied is f prime g minus fg prime all over g squared. And if you look at this compared with the product rule, it is virtually identical, except for the fact that in the numerator we do have the similar pattern. There's still that f prime of g, here f prime of g, fg prime, fg prime. The only difference is with the product rule we have a plus between those terms, and with the quotient we have a minus between those terms. So that's a way to help you remember these two rules. First, that they are very similar. So if you know the product rule, then essentially you have a portion of the quotient rule memorized. But then the difference is that product rule has a plus sign and the quotient rule has a minus sign. And in addition, the quotient rule also has this denominator being the g of x quantity squared. Okay, so let's apply the quotient rule for this rational function, 3x minus 2x squared over 5 plus 4x. We can apply the quotient rule. We have a numerator portion and we have a denominator portion. We'll let the numerator be f of x. We'll let the denominator be g of x. And then we're just going to step through our quotient rule. First up is f prime. So f prime is just the derivative of my numerator because my numerator is my f of x function. 3x turns into 3. 2x squared becomes 4x. So we put that in this space here. Times g of x. G of x is the original denominator. So we leave that as is, 5 plus 4x. Okay, minus f of x. So the original f of x function, that's the numerator. So we put the numerator in this space, 3x minus 2x squared. Times g prime. So g prime is the derivative of the denominator. So 5 goes to 0. 4x becomes 4. Okay, so 4 will be my g prime of x. All over g of x squared. So all over my denominator, quantity squared. So 5 plus 4x quantity squared. Okay, so again, we could clean this up by expanding numerator and denominator, but we're just practicing the quotient rule. And this is essentially the derivative function, but we can put it in a different form if needed. Okay, some other notes. We can take higher order derivatives, meaning that we can repeat the derivative process over and over again. And when we do that, we are going to be increasing the derivative function's name. So if we find the first derivative, that'll be y prime. And if we find the derivative again, that'll be y double prime. And then derivative again, third derivative, and then the fourth derivative. And here are the notations for that. Okay. So here we can find the derivative of each term. So this becomes 10x to the fourth plus 4x cubed minus 9x squared minus 16x plus 10, and the constant drops out. So that's our first derivative. We can find the derivative of this function again. That will get us to the second derivative. So bring down the 4, we get 40x cubed plus 12x squared minus 18x minus 16. 10's a constant, so we'll go to 0. Keep going. We get 120 squared plus this becomes 24x. 18x becomes 18. Constant drops out. And then 120x squared becomes 24x. 24x becomes 24. 18 goes to 0. So as long as we're dealing with polynomial functions, if we find the derivative enough times, all the terms will eventually go to 0. Right? The next derivative here, 24, will drop out. And then the two derivatives from here, the 240x will turn into 240 and then goes to 0. Okay, a note about notations. First derivative function can take on a lot of different forms. F prime of x, g prime of x, y prime, dy over dx. Or you may see something like this where it's d over dx of g of x. Okay, this will also mean that we want to find the derivative for g of x. So this is would be the same as would mean the same thing as g prime of x. Okay, for second derivative, the notation you may see is f double prime with the 2 tick marks, y double prime of x, or just y double prime, or you may see d2y over dx2. Okay, so first off, dy over dx means we want to find the derivative of y with respect to x. We want to find the derivative of the dependent variable y with respect to the independent variable x. d2y over dx2 is just another notation for the second derivative, and we have to be careful because this is not the same thing as asking you to find the derivative of the first derivative of your function and then squaring it. Okay, so some students have taken this to mean that, but this means second derivative. This does not mean square the first derivative function. Okay? And then the notation for third derivative, you may see f triple prime of x, y triple prime, and d3y over dx3.